Hope that works.
Yep, I see you there.
Cool.
So you got a function somewhere?
We defined it. I have everything except the phase shift. I'll type in what I have though.
Yeah, type what you got. And is it supposed to be a sine or a cosine, or does it matter?
Oh, sine. I already did the cosine part. And then
Jamie, do you have a similar project?
I do, but I already got the sine graph right.
And it's different points for you or different?
Relatively equal, but like different.
Okay.
I don't have that point, and then I have that.
All right.
I just need the C point.
Okay, well, just put for now, just put C, letter C there, and add a slider. And then good. So we got it right there. So Jamie, how did you find C? What was your method? If you
To
recall.
find C, do you mind if I grab my notes real quick?
Yeah, that's fine. So Niko, go ahead and hit the play button next to C there, and you're going to see kind of what's going to happen there. So see how it's moving. You can pause it and then just slide it to kind of get close. So yeah, keep going there. Move it a little more. Too much. Not
There.
enough. So to me, it's still. Well, that's what I'm not sure of. It's like how accurate was this supposed to be? And like for is
okay.
it's supposed to be a dead on graph, or is it just like a regression where you get the best?
It's kind of the best fit because I know my cosine graph is not completely accurate. Like there's some outlier points, but it's most of them are touching. Yeah.
That's where I asked Jamie, like, did you get a perfect fit, Jamie, or did you kind of, or is it slightly off?
Mine's really close, but it's slightly off. And then to find C, by the way, what you do is you take like, so like the sine graph normally starts with the bottom at 0, right?
Yep.
Mhm.
Goes up.
So what's your first point, Niko? It looks like 31 on there with the bottom at 0.
Oh, the bottom at 0. It's 31. Yeah.
Yeah, I had the same one. And then you divide it by your B.
By B. Okay.
Like the 14 there.
Just the 14. Okay. Perfect.
So you'll get something probably pretty close to what you've got now.
Let's do that.
Roughly. There are other approaches. That's where it depends on how accurate your graph needs to be. I would argue your graph is, I don't know, there's places it looks great and places I'm like, well, maybe it's not quite right.
That's what I got for C.
And I don't know if it matters, but is it minus C?
It depends. It can go either way. But go ahead and do a minus there. But I don't think you're gonna get it.
Yeah.
Yeah.
Wait.
Your 8.8 was much closer, or 9 even.
Yeah.
9 was very,
Niko,
very
what'd you divide? Like how'd you get 0.497?
I got, you told me to do 31. My point's 31, and then my B is 14.
Okay, because it should be like over 2 with 31 divided by 14.
What do you mean?
31 divided by 14.
Yeah, it's 2.214 is the phase shift, and then you to do it for C isn't like that. Isn't C like?
Well, that's the number you put for C right there.
Oh, 2 point. Oh, that's it. Okay. Oh, because I was calculating something different, and then I used that other equation. So just 2 point.
Yeah.
Thank you.
Mm-hmm.
So it's close.
Yeah.
Mm-hmm.
I don't know. Is it good enough? I would argue it needs to go a little more to the right, but you know, like maybe go another little bit.
Like 2.5. Yeah.
That looks pretty good.
That looks good to me.
Yeah.
You know, depending on how your instructor grades it, you know, that could be great. All right, Niko, I'm gonna go back and share my screen in just a moment here. Let me see what Jamie sent over for us to look at together.
Yeah, I just want to learn the general concepts. So any of those problems work.
I'll stop sharing.
Just sent the whole.
Yeah, so I see unit vectors, I see magnitude stuff, and then how to write vectors
Mhm.
and sketching. Yeah, I mean, we can do kind of a whole lesson on this, but let me share my screen and we'll get started on some stuff here. Niko, please send over some stuff you'd like us to look
Yeah.
at if you can. So like, let's define, you've given me some problems here. Let me go see if I can find one that's got a decent starting point here. Not like any of these problems. All right, so let's say that u is equal to -2 I hat plus 5 j hat. So your book uses boldface for I and j. In some courses, you'll see hats, these little, I don't know what to call them, but they're hats there. And you can just think of that, that's the X direction and that's the Y direction. Okay, so if we were to graph this, you would go -2 left, 5 up, and you get something. Actually, this isn't drawing quite right. Let me go move this down. 2 left, 5 up, 1, 2, 3, 4, 5. So, and you put an arrow, you got an arrow from where you start to where you're going, like this. Okay, now the next thing I could ask you is for the magnitude of u. The magnitude is using these two vertical lines. Some books, your book uses 2 lines. Occasionally you see single lines around it. Just clarify if it's unclear, but it's the distance formula. It's the square root of x squared plus y squared. And
Okay.
x refers to, in this case, -2 squared plus 5 squared, square rooted. So the answer here is 29, square root of 29. And that's the magnitude. And the magnitude is just this right here. The other thing that you can be asked for is the direction. So the tangent of theta is y over x. So let me try and circle some formulas you need to know really well. If you guys have taken physics, I don't recall if you have or not, but this comes up a lot in the beginning part of physics. So the tangent of theta here would be y over x, which I think was 5 over -2. So theta is your arctangent of that right there. Now, what's interesting, you guys, either of you have a calculator handy?
Yes.
Could you do the arctangent of 5 over -2 and make sure your mode is in degrees for the moment? We'll maybe move back and forth if we need to between them. You guys have a number for me on that? Either one of you?
I got -68.19.
Yeah, so you actually get this angle right here, -68 degrees, because arctangent, and you know this from your trig course, it's only defined from -pi/2 to pi/2.
Mhm.
So you got to be careful, like, because your instructor is going to want a different angle. Like, they actually might want this angle right here. So you just got to be careful that you actually give them that angle.
So do you
and
do
that-
like 180 minus then?
Well, let's add, there's a lot of ways to do it. Let's add 180 to go this direction. So
Okay.
if you add 180 to it, and the answer is it depends on the quadrant you're in. 111. So what is 111? 111 is the angle from here. It's 111. So if you want this angle right here, it's 180 minus that, which is 69 degrees. Or yeah, 111.8 decimal points. So the point is just be careful that you actually know, like if you say, oh, my angle's -68 degrees, while you're correct, you're wrong in the context of this problem.
Got it. Okay.
Okay, so some other things you were asking me about, and we'll do another example here, but unit vectors. So unit vectors, you take your vector and you divide by the magnitude of your vector. Okay, so and what it is it's a vector of length 1. That's why it's called a unit vector. A vector of length 1 in the same direction. And I don't expect that to mean anything to you guys, but that like it's length 1 here. So I'll show you how to actually do it, but you're probably like, why does this even matter? But so your u was oh, here's another way it can be represented, -2, 5. So you can use angle brackets for your vectors. And then we already
Okay.
found this number is the square root of 29. So what some instructors want you to do is it's like you divide both of these. So it's -2 over square root of 29 I hat plus 5 over square root of 29 j hat. Okay, now you may be expected to rationalize this. And so as a reminder, it's -2 square root of 29 over 29 because you multiply the top and bottom by the root of it. So 5 square root of 29 over 29 j hat. Okay, and if this is truly the unit vector again is the vector divided by the magnitude of it, then the distance formula of this should yield 1. So is -2 square root of 29 over 29 squared plus 5 square root 29 over 29 squared square rooted. Does this equal 1? So this is on top here. It's 4 times 29 over 29 squared plus 25 times 29 over 29 squared square rooted. And so in the, so you can combine these, it's 29 squared. The top, you could factor out a 29, you get 4 plus 25. So that 29 cancels that 29, that 29 cancels that 29.
Oh, wow.
So it does work.
Mhm.
Okay. So I've shown you once, you should not do all this, but that was just, we need a little explanation. But so you're going to be given, and here's how we kind of summarize, and we can do some more problems with it. If you are given a vector, you should be able to write it in all these different forms. So the forms are like x I hat plus y j hat, x comma y, like this. And then there's some others. There's like component forms. There's all these different things. So just keep all that in mind. Second thing is you should be able to determine the magnitude and direction. And so that's the magnitude of u, which is the square root of x squared plus y squared. The tangent of theta equals y over x. Okay. And then the third is the unit vector.
Got it.
And this is kind of, okay, if you can do all that with a given vector, and we should like pick a problem here for us to look at. So the most common one here, I'll give you, let's say that v equals 3 comma -4. Could you guys find the magnitude, the direction, and then the unit vector? So just maybe take 2 minutes, and then I'll work this out also for you. Okay, do either of you need more time on that?
I'm almost done.
Almost done.
Okay. I've worked it out here. Any questions on this?
Not really. It
About
makes
you,
sense
Niko?
now.
How about you, Niko?
I
Any?
got,
You
I
got
got
it.
it. Yeah.
The angle is probably the only one really to just be pay attention to. Here it worked out because it was there, but if they wanted the other angle, you'd have to do something with it. This comes up a lot in physics classes. I had a very difficult physics instructor in college who he would get very upset if you wrote -53 as an angle, because he would say, how can that be? And I mean, in some ways he was right. So just keep in mind what your instructors want here. So Jamie, maybe since you brought this topic up, maybe look a little bit more into those questions and see if there's any that kind of stand out.
Okay.
Because I'm going to just transition to Niko sent over a question about is the fire lookouts, Niko?
Yeah, 8 and 9. Please.
8 and 9. Okay. Yeah, the main problem with this one is trying to draw the picture. And without the right picture, you got no chance. So this is the hard part. It's like, well, what does that mean? So in truth, I had to look to remind myself. So it says go south, and then if you're going south, then go 65 degrees to the east direction. So that puts you, this angle right here is 65 degrees. And you go some distance, which we don't know, like that, and whatever. There's a lookout. Lookout. A fire was okay from A. Okay, sorry, I'm trying to get. So the next one, you go north, then you go 50 degrees east on that. So this right here is 50 degrees. Okay, and the last one, if this is A, it says from A, bearing of north 8 degrees from B. So you're going from B. So like if you draw your new crosshairs on that, you first go north, straight up and down, and then you go 8 degrees. So this right here, sorry, right in there, that's 8 degrees. Let me know if you try to follow that and see if that is if that's doable.
Got it.
That makes sense.
Okay. So sorry, I didn't make this clear. This is the fire. I gave the wrong things here. Fire's there, and A and B are here, and this is the 20. Now maybe I think it looked like you were starting to go this way, and that's okay, but you really got to pay attention to these. This has to be your guiding way of doing it. All right. So if you got this, then then you know that this angle right here is 40. This one is 25. So the whole thing is 65 there. Why does that help? Not sure at the moment. Is that right? Because we're going to use like a law of sines or law of cosines here. So this angle right here is 65 also. This one right here by parallel lines and transversal thing. And then, so that makes this whole angle 73. And then you can get the third angle up here. So I guess if I got this far, I probably would redraw it without all the extra stuff that I have here. So this is 65, this is 73, and then the third angle is 180 minus those two. So what does that give us? 42. And we know that this is 20. And I guess we want this right here. We want this distance here.
Can you explain how it's that bottom is 65 again on B?
So the from this was given 45 degrees. I'm sorry, 50 degrees. And then with the horizontal here, that these have to make 90. And then similarly, if this is 65 because it's given, then this has to be 25 because that has to make 90 also. And oh, I'm sorry, down here you mean?
Yeah. You said it's
Okay,
like
I'm
parallel-
sorry.
parallel
Yeah.
lines.
Okay, so you got, imagine your crosshairs are there. You're going, this is horizontal. This is horizontal, and it's, I'm sorry, vertical. Using the wrong language. If this is 65 degrees, this is the transversal. So these are alternate interior angles.
I see. Okay.
Sorry, and you do have to, that you can't do it without that. You have to know that little bit there to do it.
Perfect. Thank you.
Okay, so then law of sines, yeah, law of sines. So if x over sine 73 equals 20 over sine 42, and then you solve for x is 20 sine 73 over sine 42. You get some number in miles here for that. I'm going to run through question 9 just because it's kind of related to this before we move back to some vector stuff. You guys want? So I think this one's more straightforward because it says like, okay, start here and do this and then do this and do this. And those tend to be easier to explain. So A travels 500. So like we considered A right here. A is your origin, and north 32 east means you go north, angle 32 to the east. So you go there. And so this right here is the 32 degrees. And we know that this is 560 miles. Okay. But then from here, you have to restart your crosshairs. You say, okay, now I'm going south 72 degrees. So you're going south, but then you're swinging out 72. So this is 72. And you go some distance, 320 miles. Okay. And they want you to find the distance here between the two. So A, B, and C. And so if you get all that, you might, again, you might just say, well, let me just redraw it here and see if I can get a little cleaner. The kind of just like the last problem there, Niko, 32 is here and 32 is also there by the alternate interior angles. So that gives you 104 degrees in here, 560, 320. So this is a law of cosines because you've got side, angle, side. We want the distance here. So c squared equals a squared plus b squared. That's from the Pythagorean theorem, minus 2ab sine big C. D squared equals 560 squared plus 320 squared minus 2 times 560 times 320 sine 104. And then don't forget to take the square root of all that when you're done. Also, again, always make sure you check your mode. You know, this time you do want it in degrees. So whether, I don't know what this is from, but it looks like you're going to get one law of sines, one law of cosines. It does look like you want to run through again, you know, these sort of angles here and make sure you're comfortable with it. The first letter tells you like which way to start, and then the other letter tells you which way to swing, because it could just as well be west or something. But who knows what the instructor has in mind. Niko, does that take care of that? Do you feel like you understand how to
Yeah,
work through those?
I just had trouble
Okay.
with the bearings. Makes a lot
Yeah,
of
me
sense.
too, because nobody uses them. Can you imagine talking to someone like that? Like, oh, and like on a soccer team, like, all right, why don't you go
Yeah.
north and then swing 42 degrees to the east and I'll hit you there.
Yeah,
It wouldn't work.
yeah.
All right. So, Jamie, have you had a chance to look over vector stuff? Any other things that come to mind?
I think I'm starting to get them. They're making more sense now. That's for sure.
Okay, so another thing is I could give you, go ahead, sorry.
If there's like, sorry, there's like something I'm looking at. There's like a graph already with like a V and a U,
Yeah.
just like labeled lines.
Mhm.
And then one of the problems is like drawing 2U. Is that just like extending U to double its size?
Yes, and there's
Okay.
other things we can do.
That makes
Yeah.
sense. Then.
So let's do a few of these. So let's say I tell you that the magnitude of U equals 10, and I tell you that theta equals pi over 3. So the way you find X and Y is you go the magnitude, you go U cosine theta, U sine theta. And these are the magnitudes. So in this case, it'd be like 10 cosine pi over 3, 10 sine pi over 3. And like in one of these, it works out nicely. Cosine pi over 3, I think this one's 5. This one's 5 square root 3. Okay, so you can go backwards, and what that means is this is 5 comma 5 root 3 in your bracket notation. 5 I hat plus 5 square root 3 j hat.
Mhm.
They use dots, which maybe that doesn't make sense here, but
Like if it's bolded, they just use dots.
yeah, they just use
Okay.
that. They use they actually have that there if it's bolded.
Okay.
Trying to think of some other things that might be of use here. J dot. So just to go back, yeah. So what, like then you can do algebra sort of with vectors.
Mhm.
Okay, so if I tell you that U is 2 comma minus 3.
Okay.
Minus U is the first thing we do. It's changed the sign. It becomes minus 2, 3. So graphically, what does that look like? Well, 2 minus 3 is down here.
They flip.
It flips right
Okay.
up there. Okay. So when you get into other courses, they'll ask you things like, give a unit vector not in the same direction as
Okay.
you, and they just want you to go the other direction.
Gotcha.
Okay.
Okay.
You can also do like 2U. 2U means you double these things. So it's 4 comma minus 6. So if this is U, 2U goes, another 2 and down like that. But it's the whole thing.
Okay. That makes
Right?
sense.
You can also do addition and subtraction. So I can give you two vectors. I can say U is 1 comma minus 3, and V is 3 comma minus 2. And I could say, what is U plus V? And you would say, well, it's 4 comma -5 because you just add them together. But graphically, this is where it's kind of interesting. Graphically, 1 minus 3 is here, and 3 minus 2 is here. Okay, so how do they get 4 minus 5? Well, you and I can do this. I think I can do this here. You actually take one of them and you slide it, and they call this head to toe.
Okay.
So the head of that one goes to the toe of the other one, and you can see what's called the resultant. Again, there's a lot of physics reference here. This is your resultant, is the 4 down 5.
Okay.
Okay, and
it would work either way.
yes, and that's so there's these like there's the like commutative law of vectors, of adding vectors, which says that u plus v equals v plus u.
Okay.
Now you could similarly subtract them. So let's do that. Niko, how are you doing following along with this?
Good, I'm writing it all down. Got it.
So we could do u minus v now. So you take
Okay.
1 and you subtract 3, so you get -2. -3 minus a -2 gets you -1. So how does that happen? Well, let's go look. So one way to do it is you start with u. U is 1 minus 3 like we had before. Now 3 minus 2 is down here, okay? But when you subtract it like we saw, you actually flip it. So it's really -3 comma 2 plus 2. So it's really like going, it's really this way now. But you don't do it there. You slide it down to here.
Oh, wow.
Okay, and then you can see the resultant on that, which is consistent with what we have right here. Some instructors, they want you to get your rulers out and do it really accurately. It's kind of like going back to geometry. It's like, well, how accurate do I need to be? Maybe ask those questions. So a lot of things are treated like vectors, believe it or not. So you guys both play soccer, right? So you kick a ball. It's a silly example, but you kick a ball, it goes like that. But at each point in time, you could draw little arrows indicating little vectors, identifying what's going on, unit vectors, because it's actually changing over the course of its trajectory. Another kind of interesting use of unit vectors, which you don't see much of in this course, but a plane, and you're thinking, what do you mean plane? A plane is a three-dimensional surface. A plane like this is identified by what's called its normal vector, which is what you just, it's a unit vector that's orthogonal to the surface. So if you guys ever take calculus 3, you'll learn about that. But that's the real use. That's the real power of these things is being able to describe a three-dimensional surface with just a vector. And look, I didn't make this up. This is the math world. I mean, it's a little weird, but that's what it is.
Okay.
Niko, do you have some other stuff you would like us to look at? Yeah, there's another one on the worksheet. It's just the first part. I just can't figure out.
Oh, so when you guys are walking around campus, you might, and this, I mean, you don't say this to anybody, but you might envision your trajectory as like a vector. You're walking here, someone's walking there. You might see the paths, the collisions. You probably do this without even being aware of it. And then you slow down, or they speed up, or things like that.
I sent it over.
All right. There it is. All right. Snip this in. All right, after a storm, a tree is leaning 3 degrees from vertical toward the front of a house. Okay, so I guess I would take that to mean that if this is the vertical, the tree, this is 3 degrees right here. A person standing on the front porch notices the angle of elevation to the top of the tree. And we don't know yet whether it's at the same height as the tree, but they're saying the angle of elevation is 40 degrees here. And then this right here is 60 feet. Jamie, have you already done this problem?
I think so.
Okay. I was just asking if you remembered this being the correct picture.
Yeah, that is right.
Looks right. Okay. So Niko, when you look at this, what are we trying to find here? Are we trying to find, let me label some sides here, A or B?
We're trying to find A.
Trying to find A, yeah, because like supposedly the tree was straight up and down.
But it's
And then
tilted.
Yeah, we don't have, I mean, all of the mesquite trees I see around here, they grow like that. But this does happen. So they want A and they've got the angle across from A, 40 degrees. So that's kind of like, well, maybe it's law of sines. We really need another angle here. Jamie, how would he find this angle?
Wouldn't you find it by 90 minus?
Yes, because there's the assumption, and there's a lot of assumptions here that the tree was going straight up and down from the ground. So this is 90 minus 3 or 87 degrees. And once you have two angles, you immediately find the third by adding them up and subtracting from 180 or subtracting from 180 and doing that. So what does that give us? Like 53 degrees probably?
Yes.
Yeah.
Okay. And the reason that's useful is because now you have another angle side pair. And that's what you really want for law of sines, angle side pairs, basically the angle and the side across from the angle. So we're interested in finding A. You write A over the sine of 40 equals the side that we know, 60 over the sine of the angle across from it, which is 53. So just cross multiplier, just clear out the sine 40, 60 sine 40 over sine 53. You get a number there. Okay, now as kind of an aside, let's say we all three of us owned a construction company and there was a tree leaning and they wanted it cut down and we charged by the foot. How would we, do you think we would actually do this to figure out how tall the tree is?
I don't know.
Probably not.
Like how did they know this was 3 degrees? I guess is kind of my first question. You think that's reasonable to know that?
No.
I mean, it's tough. I mean, you'd have to somehow know that it went up and over and up, like it was the same. Do you think somebody has an angle of elevation thing?
Probably not.
I don't know. I mean, I don't have one. Maybe you guys do. I mean, these are kind of obscure questions. I think we would probably try to, affix a rope or something, throw something up and measure it, see, how big the tree was. Or go straight up, straight down, right? Measure these two distances find the third. Maybe make a right triangle there. I don't know. I want to, these are kind of, these problems are just textbook problems. You would never do this in real life because you generally don't get angles.
Mhm.
So, and on a broader scale, as you guys know, the earth is curved. So, that kind of throws everything into problems when you get far enough away. But most things we do, we consider flat surfaces, and it's a good approximation. But from here to the eastern half of the United States, there is some curvature to the earth to be accounted for.
Mhm.
All right, what else do you guys want to look at today?
I think
Um,
I'm good.
That might be everything I need.
One last point I'll make on vectors is vectors are, you're seeing them in 2 space. You will see them in 3 space. So that's your x I hat plus y j hat plus z k hat. And again, if you haven't seen that, I mean, there's x, y, and z. You may see that here coming up. And then 4-dimensional space, which we don't know about, but you can actually express it with just continuing on with letters here, even though we don't know what to call it. At least I don't. But that you can actually go on forever with spaces.
Hmm.
All right. Any final questions, things you guys want to look up?
Yeah, I think I'm good. Thank
Niko?
you.
You're welcome.
I'm okay. Thank you.
Okay. I just keep asking a couple times. Thanks, guys. I'll send you the notes here shortly, and I'll see you next time.
Thank you.
Okay,
Great
thank you.
night. Bye now.
You too.